Good afternoon. Today we are going to see the solution that is of problems. Day 2 exercise 2 part 1. So we have hollow shaft has 75 mm external diameter, 50 mm internal diameter. Determine the twisting moment it can resist if permissible shear stress is 110 MPa. So now we have to find the value of torsion. So formula we have. So first we will write given data. So whatever given, be habitual with this in examination is always preferable. So if question goes wrong, then you will get some mark for this. Given data. So we have capital D that is equal to 75 millimeter. Small d, this is equal to 50 millimeters. Shear stress is given, that is tau is equal to 110 MPa. And we have to find value of T. So formula we have T by J, this is equal to tau by R. And then J we can have J equal to pi by 32 D4 minus D4. And we have pi by 32 D we have 75 to the power 4 minus 50 to the power 4. And we have this value 2.49 into 10 raised to 6 millimeter to the power 4. And now we can have T that is equal to, already we know T by J, so we have T upon J 2.49 into 10 raised to 6 equal to 110 upon R. So maximum diameter is external 75 by 2. And from this we will get value of T that is equal to 2.49 into 10 raised to 6 into 110 into 2 divided by 75. So just I will check once. 2.49 into 220 divided by 75. 7.3 into 10 raised to 6 Newton millimeters. So this is first answer. So T for hollow is 7.3 into or 7.3 kilonewton meter. First part of this. Second, determine the diameter of solid circular shaft made of same material which can transmit same twisting moment. So we have to find now T solid, we have formula pi by 16 d cube into tau. Now how it comes, already I explained this, T by J. J we have pi by 32 d to the power 4 for solid upon tau divided by T d by 2. So 2 gets cancelled, it becomes 16, and 1 d gets cancelled, it becomes d cube. And therefore we have T is equal to pi by 16 d cube tau. And therefore I will put value of, therefore value of T we have same that of solid. So 7.3 into 10 raised to 6 equal to pi by 16 into d cube, and tau we have same 110. And from this I will get value of d solid equal to, so if you will solve this, 7.3 10 raised to 6, 16 divided by 7.36 into 16 divided by pi into 110, and to the power 1 by 3, we got this value 69.66 millimeters. This is second value. Third, hence compare the weights, and G is given 80 GPa. We need not require this. Now weight, what is formula for weight? So we have weight that is equal to unit weight of material, unit weight into volume. So we have gamma into area into length. So we have weight of solid divided by weight of hollow. Now material we have same, so gamma we have same, area we have for solid, length we have same, divided by gamma same, area of hollow into L. So this gamma gets cancelled, L gets cancelled. So always keep in mind, weight of solid by weight of hollow is nothing but area of solid divided by area of hollow. Now area of solid we have pi by 4 into d square, and value of d we got 69.66 square, and area of hollow we have pi by 4, and we have external diameter 75 and internal diameter 50. And then pi by 4 gets cancelled. So keep in mind, so you can have weights that is equal to diameter of solid square divided by d square minus d square. If material is same, length is same, you can use this formula directly to find out, to compare the weights. And we have this value 1.55. So weight of solid is 1.55 times weight of hollow, and therefore generally solid shafts are not preferred, because in solid shaft your shear stress is 0 at center and maximum at end, whereas for hollow shaft we have, so average will be by 2, but in case of hollow shaft we have between these two only. So this will be trapezoid, and average of this is much higher than this average, and therefore hollow shafts are preferred always. Now second, design the cross section of hollow shaft for which internal diameter is 3/4 of external diameter. So we will go first with given data. So we have given small d equal to 3 by 4 of capital D, means 0.75 of capital D. Then we have given that is torque 2000 Newton meter. So T is 2000 into 10 raised to 3 Newton millimeters, such that shear stress does not exceed. So we have seen that problem we have actually 120 Newton per mm square, and twist 2 degrees for 2 meter length. Sorry, tau we have taken, just I will check it. So tau in question, that is taken as 110. So this is taken as 110. So now you just check it. If you have 120, then keep as it is. but whatever I have taken it as 110. So now we have given tau 110 Newton per mm square. And we have to find cross section. So now we have formula T by J that is equal to tau by R. So the value we will get from this will be strength criteria. Strength criteria. And second value we got T by J is equal to G theta by L. This is stiffness criteria. And maximum of the two we have to consider as diameter. So now we will go with this. So now we have hollow shaft. So we will find value of J. So we will get therefore J this is equal to TR upon tau. And then T is given 2000 into 10 raised to 6. So I will write this T upon R. J upon R I will write. And that is 2000 into 10 raised to 6 divided by tau. Tau is 110. Now from this we will get value that is J by R. Now J we know we have this as solid. So we have pi by 32 D4 minus we have this value 0.75 D. So I will take it as 0.75 D to the power 4 upon R we have D by 2. And so we have this, we have equal to 2000 into 10 raised to 6 divided by 110. Now this 2 will get cancelled with this 16 and we will take pi by 16 d to the power 4 outside in bracket 1 minus 0.75 to the power 4 divided by d. And that is equal to 2000 into 10 raised to 6 upon 110. And from this gets cancelled d. So we have d cube. And from this we can find d cube. This is equal to 16 into 2000 into 10 raised to 6 divided by pi into 110 into 1 minus 0.75 to the power 4. And from this, and therefore from this, we will get value of d equal to. So just I will calculate it. 2000 to the power 3, sorry. 2000 to the power 3 we have to consider. So I have taken 6. So this will be 3. 3. So 3. So 2000 to the power 3 divided by pi into 110 into 1 minus 0.75 to the power 4 and to the power 1 by 3. And I got value 51.36. Now you check it. 51.36 millimeter. So 1 minus 0.75 to the power 4 multiplied by pi multiplied by 110. And x inverse multiply by 16 into 2000 to the power 3 to the power 1 by 3. I think 51.36. So if I will take it as 120 into 1 minus 0.75 to the power 4 x inverse multiply by 16 into 2000 to the power 3 to the power 1 by 3. Yes, 49.89. So if you will take tau 120 mid Newton per mm square, then you will get value of D. I don't remember exactly. You will get 49.89 mm. So just check it 120 or 110 and accordingly you can have these values. Then we have second criteria T by J, and from this J we will get equal to TL upon G theta. And now T we have 2000 into 10 raised to 3. L we have 2000. G is 80 into 10 raised to 3. And theta pi by 180 into 2. Now this 10 raised to 3 gets cancelled. And from this we will get value of J, which is pi by 32 D4 minus 0.75 D to the power 4. And that is equal to 180 will go up. So 2000 into 2000 into 180 divided by 80 into pi into 2. And then from this you calculate D4 equal to, this 32 will go up. So we have 32 into 2000 into 2000 into 180 divided by, now this pi become pi square, 80 into pi square into 2 into 1 minus 0.75 to the power 4. And from this you calculate value of D. So we have, just I will check, 80 pi square into 2 into 1 minus 0.75 to the power 4 x inverse multiply by 2000 square into 180 into 32 to the power 1 by 4. And value is 67.96. 67.96 millimeter. And therefore, this is greater one. We have to always go for greater value. And therefore, provide D is equal to 68 millimeters. And a small d becomes 0.75 into 68, which will be 51 millimeters. So likewise, we have to go for solution of this diameter. So we have, this is second problem. Third, we have a circular shaft 150 mm external diameter and thickness of metal 20 mm. So given data, capital D is 150 millimeter. And now 20 millimeter thickness, so small d becomes 110. Already we have seen many times, we have thickness from both sides in examination. You should be very careful, otherwise student commit mistake. So we have, this will be 20 and this 20, and therefore internal becomes 110. External we have 150. Then 250 RPM. So we have given n equal to 240 RPM. Then we have given theta 3 meters. Theta is 0.7 degrees. So pi by 180 into 0.7 radians. Calculate power transmitted. So we have, first we have to find T, and we have hollow shaft. So T by J is equal to G theta by L. Tau is not given. So G is given. So not given. So we have to assume 80. I have assumed, I will check it. Yes, 80 into 10 raised to 3 MPa. And then we have T by J is equal to G theta by L. J we will get it as pi by 32 into 150 to the power 4 minus 110 to the power 4. And we have this value. I have not calculated separately actually this value. So this I will keep as it is, and therefore I will calculate T, that is equal to pi by 32 150 to the power 4 minus 110 to the power 4. G is 80 into 10 raised to 3. Theta we have pi by 180 into 0.7. And value of L we have 3000. So if you will calculate this value, pi by 32 into 150 to the power 4 minus 110 to the power 4. So it comes 35.33 into 10 raised to 3 millimeter to the power 4. And substitute in this, you will get value of T, that is equal to into 80 to the power 3 divided by 3000 multiply by pi divided by 180 multiply by 0.7, and we have 11.51 into 10 raised to 6 Newton millimeter. Convert it into Newton meter because we have to find power, and in power value of T is always Newton meter. And then we have P is equal to 2 pi nt upon 60, and that is equal to 2 pi n is 240 upon 60, and T we have 11.51 into 10 raised to 3. So this becomes 4. So 8 pi. So we have 8 pi into 11.51. It comes 289.28. So 289.28 into 10 raised to 3 watt. Therefore, we have P is equal to 289.2 watt kilowatt. So likewise, we have to solve the problems related with your power. So now we will stop here only. Remaining part we will see in the next video. So thank you.